Have you ever wondered how large language models understand the context of the information they are trained on? Embeddings and vectors play a crucial role in this process. This video explores the significance of embeddings and vectors in large language models. It also explores how you can use MarkLogic Flux to add vectors to data. Embeddings represent words or chunks of text as numerical values, known as vectors. Vectors help LLM models identify patterns and meanings. First, a document is broken up into smaller pieces known as chunks. Next, a model transforms the chunks into numbers that represent context to a machine. Think of vectors like GPS coordinates. San Diego, California, and Tijuana, Mexico have similar latitudes and longitudes. Thus, they have similar GPS coordinates. A city like London, on the other hand, is far away and has very different coordinates. In much the same way that similar concepts have similar vectors while different concepts have dissimilar vectors. In this example, you can see that the text in the chunks is about very different topics. As a result, the vectors are substantially different. Without embeddings, models would struggle with nuanced understanding. To create embeddings, MarkLogic Flux can use any embedding model supported by the LangChain 4J library. In this video, I'll use the MiniLM model. Download the jar file for this model from the releases page and follow the installation instructions. See the description below for more information. Once I have the MiniLM model configured, I can add embeddings to this President's JSON lines data that I've used in other videos. To do this, I'll use this command. This line contains the path to the source file. This is the connection string. Replace the user, password, host, and port number with the values for your environment. This command splits the description field into 500-character chunks. The chunks are stored in separate or sidecar documents belonging to a collection called chunks. This command indicates the MiniLM embedder will be used to create the embeddings. After running the command, I can look at Query Console and see a sidecar document with a large number of vectors. If I have a large number of documents or speed is a top priority, adding embeddings can make documents quite large and decrease model performance. To avoid this, I can use 64-bit encoding. 64-bit encoding creates smaller documents, results in faster network transmission, and enables more efficient indexing. To encode the documents, I'll add this line to the command. Notice I have also changed the collection name. After running the command, I can use Query Console to find a sidecar document in the base 64 chunk collection. By clicking on the document, I can see that the vectors are encoded and the document is substantially smaller. Another useful feature is the ability to prepend a prompt to each chunk before sending it to the embedding model. This can be useful for providing subject matter context or instructions that can improve the quality and relevance of the generated embeddings. For example, in our president's data, it might be useful to pass the prompt historical background about a US president to help the model identify the subject matter. After running the command, Query Console shows the vectors. Based on the prompt I added in the last step, the vectors have changed and better represent the intended meaning of the data. This makes it easier for machines to find semantically similar documents based on a search query. This video has introduced the concept of embedding and how to use MarkLogic Flux to add vectors to your data. For code samples, links, and additional resources, see the description.